You'll lose your best TA ever. Oh no. But yeah, so yeah, we're start now and just go for it. It just should be enough for the final, by the way. Like it should be enough. I hope to God it is. If not, I'll let you guys know. But yeah, this is the first part real quick. DC recurrence theorem. Little recap of what it is. Basically, we're gonna let T of n equal to A for T n over B plus F of n, where A is gonna be the number of subproblems and B is gonna be the size of those subproblems, and F of n is just a function or just the time to solve these subproblems. And then the most important part is the bottom part, which is there's a constant called C, and it's going to be part of this function called where A times F over N over B will equal C F times F of N. And the solution is going to be based on if it's less than, greater than, or equal to 1. And for this, going to be if it's less than, we're going to do F of N. If it's greater than, we're going to do this horrible, horrible time. If it's equal to, which is this one. I don't want to talk about it because we most likely probably use the first one, but you never know. And just to practice this, we're just going to use the midterm one because it's actually a really useful one. And it's going to be very, very similar to like this, basically. I'll give you the comments, I'll give you the code. It should be the same questions, hopefully. But yeah, we have the pseudocode right here. Nothing, it's like pretty basic, nothing too bad. Like, and it's be the length of the array. If it's equal to 0, we're do nothing. Else, we're gonna create 5 subproblems with a length of n over 3. And this takes linear time based on the for loop, where for each subarray, low, low, mid, high, high, we're gonna call this function again, something else. But most important part is the comment. Basically, we have 5, which is gonna be the actual number of subproblems, n over 3, which could be the size, and this could be the actual function, the actual runtime for this. So we can just say that, okay, based on our theory, we can say T of n is going to be equal to 5 T over n over 3. So I think it's going to be n over 3. Let me double check real quick before I that nonsense, or I actually just messed it up, which is going to be very bad. If I mess it up, everyone's going to mess it up. So that's really, really bad. Let me double check though, just to make sure I'm not going crazy. Right. Nope, one more. Okay, yeah, bet. Just that. Okay. And no more. And we have n over 3 as the size, and we do plus O of n, where O of n is going to be linear time. And then we can just parse this just to make sure like everything's crystal clear, where A is going to equal to 5, B is going to be equal to 3, and F of n is going to equal to linear time, which would be O of n. Now to solve this, we can just call back the previous function, which is going to be A F of n over B will equal to C F of n, blah, 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 blah. We can just say A equal to F of n over B equal to C F of n. And then we can just solve this, basically, just keep going. So we can just say, so 5 F of n over 3. And just to make sure this is equal to C, we can just parse the divisor out as a constant. So we can just say 5 over 3 going to equal to F of n. And now we can just obviously see that C equal to 5 over 3. Now question, is this greater than, less than, or equal to 1?
Greater than.
Ooh, yeah. So if it's greater than, we can just say this, parse this bitch out. Whoop, duplicate, get over here. We can say if it's greater than 1, we can just say our T of s can be equal to our function. So we can just say
You
T of
picked the
n.
wrong one.
No, oh, it's less than? My bad. You're right. I'm sleeping still. This one. Thank you. Oh no, it's so bad. Get over here. Please don't get stuck. Okay. This is the right one. Thank you, Ariane. Probably said the name wrong again, but that's okay. So T events is equal to the theta of n log b, where b is equal to 3. This could be a, which is 5. That's our answer. And that's pretty much it for the final. It should be the exact same thing, except a few tips. it's gonna be based on sorting actually. So little tips for this one is if you want to memorize it, you don't have to. It'll be given to you, but it's gonna be based on one of the sorting problems, either quick, merge, selection, or basic. And it will also, on the other hand, it will be based on medium of medians. Basically, just remember the runtime for medians and medians. So just remember the runtime for this. Which is a fun fact, it should be constant. Should be linear, not constant. O of n. But that's pretty much it for this question. Should be an easy one, I hope. If not, that's okay. There's the other problem still, like MST. Unless anybody has a question for the DC recurrence theorem at all. Everyone cool with this?
If we wanted to break down the like I see what you did,
Yeah.
like for number 2, like to get C. If we wanted to break it down further, like to make it easier on ourselves, because I felt like that took like a little bit of like mental power to do.
Mm-hmm.
Like how would you do? Would you just plug in n divided by 3 and n into O of n, or
Hmm.
do you just have to go straight from there? Because I feel like I remember doing it a different, like
I mean, you can do linear. You can
way.
do some. You can use some linear algebra if you really want to do it like mathematically.
Oh no.
Yeah, exactly.
No.
Want to say, if you want to do linear, I could do it algebraically if you want to. I'm gonna be here for like a quick 30 minutes, but we can do that if you want.
I did it algebraically. I can send a picture if you want
Yeah,
of
but you can
what I
also,
wrote.
yeah,
Yeah.
go for it. You can go for it if you want. You can also do like little like the shortcuts. Just do like A's could be A over B basically if you're doing like the shortcut way. You don't have to do it like at all the way I'm doing it right now. You can do it whichever way you want to.
Wait, what's the shortcut way?
Oh, it's actually really easy. Instead of doing like n over 3, you just replace this function out of here. Just do A over B is equal to F of n. That's it. So instead of doing like everything together and just messing this horrible ass equation, just take this out. 3 F of n. This should be equal to C. So a little shortcut, you can just say C should be in theory equal to A over B. Don't do this in your papers. If you're doing a research paper, don't do this. But if you're taking the exam, you should do this.
Okay, okay.
But that should be like a little shortcut method. If you want to do no math, you want to do algebra, just do this instead.
Mm-hmm.
But that's pretty much it for this question, to be honest. Unless any other questions at all.
You may proceed.
Okay, I don't need your damn permission. If you want. So yeah, let's do a little recap of Cruise because I've been doing this the whole entire week. So let's do more Cruise. So this is based on the actual final review, and I'll actually show you step by step how to actually do this on your exam because he started to be a little bit zesty this week. So might as well do it step by step, I guess. So yeah, same steps like always. Crucibles, you can highlight every single edge, and you can draw the MST. That's it. So based on the graph up here, whoa, wow, amazing highlighting skills. We could just say, okay, what's the shortest edge based on the graph given to us?
BE.
Yeah, that one.
I didn't know you were asking us. I was like,
It's okay. So we just on your exam, you're gonna have to circle it, but for my end, because I really don't care, you can just highlight it for every single step, and we just do it over and over and over again. So BE is gonna be our first one, and the next obviously could be D to F, right? So bring this over here and do DTF next, and then we could just cross these out. By the way, this one's done. This one's done. And then obviously B to C is next because we're going to go in order of every single edge we find. And then what's the next one after 5?
ATE.
Yeah, ATE. So we highlight this again. Oh, wrong one. I have to do every single step. which this is gonna take so long in the damn exam. But that's okay. A to C, come back up, cross this out. And then obviously D to E is next. Yeah, it doesn't create a cycle yet, so we're okays. A to C, B to C, B to C here, and then finally D to E. And that should be it, right? How we visited every single node or every single vertex.
Yeah, you did.
Yeah, so we're done. So we don't need
Nice.
step 6 at all. I miscounted like always. And that's it. So at the very end, you can draw. We're gonna do both the forest and the tree. Because based on Asha's request, we're gonna do both of them. So we're just gonna draw this out real quick. I think I did this wrong. Did I do this wrong? Hold on. I swear I have so many horrible self-doubts today. We double check though. B to C. Hmm. Should be right. B to D. Yeah. No, it's not right. I highlighted the wrong thing again. Fuck. I did the wrong highlight. Hold on, just this one.
It
I
should
was
be
like,
A2, right?
yeah, A to E. I was like, I swear something's off. I swear. Yeah, A to E, B to C. Okay, yeah, now it looks correct. So you just draw the forest. What you basically draw the resulting graph you were given. So A to E, B to C, B to E, D to E, and D to F. Just draw this on your actual exam, just a forest. The tree, just a little extra because, that sounds like fun to draw. And so to draw the tree, it's going to go based on DFS or BFS, whichever one you want to go. Both, sweet, actually, DFS, not BFS. So draw E down here, trace this here. And now we have two children nodes, which is B and D. We just split it in half, do it after a quarter. If you're given this, B and D. And then finally, both of them have one children, so you can just draw B to C and then D to F. That's it. And now that's pretty much it. Does anybody have any questions for this one by any chance? I know I made a little oopsie, so you can ask questions if you want.
Do you think like the main thing we should know about crystals is just like how to like trace it? Like, should we know it's pseudocode or like it's recursive? Like anything else on it, pretty much.
No, you're good. Just know how to trace it, and then just know how to draw the actual forest at the very end. Tree's just a little bit extra, just in case it's there, but it should not be there at all.
Do you want to be here today? But like,
Okay.
Everyone else? Everyone cool with this?
That's cool. Thank you.
Okay. Yeah, let's do one more. Let's do one more just to make sure everyone's okay with it. Let's do the actual homework MST tree again. So sadly, we don't have the nodes at all on the side, so we're just gonna have to YOLO this the whole entire time. So based on this graph, which one's the smallest?
C to D.
Oh yeah, C to D. And then what else?
A to F.
And then D to F, right?
Yeah. Well, yeah.
Yeah, it's 5. Yeah, on your exam, you can just flip flop every single time instead of going up and down. And then from here, we can do which one actually? Because this one will create cycles if you choose the wrong one, right? So let's just look at them individually. So this next smallest number is 10, right? But we can't use 10 at all, only because wait. Oh,
Would it
no,
not be
my
7?
bad.
Yeah, we need
Yeah.
7.
I'm so sorry. If you can't tell, I've been graded a whole entire night. My sleep's gonna catch up to me real soon. So yeah, now with the bad problem, we can't use 10 at all, right? Because that's gonna create a cycle. Choose this edge, that's a whole ass cycle, which is bad. You can't choose 10 or 11, because 11 will also create another cycle. And 16 is also another cycle. So which one's left?
D to E. 17.
Yeah, 17. So we can just draw this. A, 2, here, cross, and then finally down. Why did I really leave one extra step? I'm really what's the point when I made this review. And so yeah, and then at the very end, that's pretty much it. Just highlight the smallest edge every single time and just keep going over and over and over again. So just draw what you have on top with the actual edges from, and then that's your forest. And now a little funsy again. Let's draw the tree again. So A has two children, B and F. So alphabetical order. B is gonna be on the left hand side, and then F is gonna be on the right hand side, here and here. B has no more children, so that's it. And then F has one child, which is D. Go here. And then D has two children, which is C and E. So alphabetical order. C goes to the left hand side, and E goes to the right hand side. And that's it. And that's your little tree. And that's pretty much it with cruise goals. On the exam, no pseudocode again, and just know how to trace it and how to draw the forest. That's it, to be honest, for cruise goals. Shouldn't be too bad, hopefully. And just remember, cruise goals is always gonna be the smallest edge, not the vertex. Prims is gonna be the vertex. And thanks to Ashish's horrible ass joke, just think as prims as the parent one, basically. But
I changed it. Primary, remember?
oh yeah, my bad. Primary. Whoa. Basically saying start at the first node, which is gonna be A, and just keep going over and over and over again. But for the exam, you do have to state the actual cut for every single step, which is gonna suck, but that's okay. At least I don't have to draw this over and over and over again on the board. I just copy and paste it. So, this also you'll be given with a starting node, but usually it should be A, the alphabetical order one. So for that A, and then let's choose our smallest edge based on A. So we can choose either 18 or 9. So which one's smaller?
9.
Mm-hmm. Yeah, so we just cross off 9, which is going to be A to E. I like this. And just make sure you state it also here as well. So for the exam, just circle the edge. So A to E. And now you have visited. Oh yeah, I forgot to skip this up. But it's fine. On the exam, it will tell you that all the cut table should be initialized already. So we can't skip the first step. So we can say A to E. So we have visited A and then E. And remaining, we have B, C, D, and F. Everyone cool with that? So
Wait, I thought it would be just A for the first step.
on your exam, it should state in very bold text, it should say your table should be initialized for you. So you can just skip the first step, which is
Okay.
yeah, which should be
Okay.
this. A, B, C, D, E, and F, which is the first step. You can skip this at all. You
Okay.
can state stuff if you want to, by the way. I won't like mispronounce you, but just to be safe, we just start here and just copy over the step we were at beforehand. Here, which is the first step, and then we just do A to E, which you have A, E, then B, C, D, and F. That's it. And so we just go back here to the top again, and now we have visited E. And now, based on E's edges, which we have 3, 17, 12, 18, what's the smallest edge?
Three.
Yeah, B to E. And then we just do it over and over and over again. Should be roughly similar to cruise codes, except you have to start at A all the times. And you can't like jump between unvisited nodes. And that's it. So we have visited B now, so we do A, E, and B. And now we have C, D, and F left. C, D, and F. And we do it one more time again. Well, we do it for 3 more times, actually. So we have visited B. And now we can just trace the next one, which should be 5, because 5 goes from B to C, compared to the other ones, which could be 17, 12, and 18, which are all pretty bad. So our next edge could be from B to C, which is 5. So we can just draw that or trace it again. So B to E. A to E, B to E, and B to C. So we have visited C now. So we do A, E, B, C, and we have left, we have D and F left. So we can finally knock off this 18 because it's already that C has been visited already. So what we have left, we have 15, 12, 17, and 19 left. So based on the smallest edge again, we have 12. Let's choose 12. This could be D to E. So based on the previous tree, we have A to E, B to E, B to C, and now finally we have D to E. So based on our table, let's update it again. We have A, E, B, C, and D. We only have F left. So going back to the top again, we have visited this, and now finally we can finally have access to 4, which should be the smallest edge left on the graph. So we just say, hey, let's just take 4 at this point. So let's just keep going again. So A to E, B to E, B to C, and then finally D to E, and the last one, D to F. That's it. So we do A, E, B, C, D, and F, and nothing's left behind because all of it has been visited already. That's it. And now we just finally trace what we have as our resulting forest, which should be A to E, B to E, B to C, B to E, and finally BD to F. And then for funsies again, let's draw the tree again. Because, I love drawing trees. Trees are the best topic in algorithms. And if anyone's new to here, I'm a very sarcastic person because I do not like trees. Trees are like the worst topic in this algorithm because it's too simple. Nothing too complicated about this. So B to C, finally D to F, which is similar to the previous tree, right? Like the forest and the tree should be the same thing based on the COSC algorithm, which is here. It's the same thing. So to make sure to double check on your exam, you can just verify based on your previous answer, like if they're the same thing, I should be okay. And yeah, and that's pretty much it for Prim's algorithm. We could do the next one, by the way, the based on the actual homework, and just do it on the same steps based on the final. So one more time. Woo! So little pop quiz. Which node do we start at, basically? And I'll give you a hint. It's off about a quarter. So which node can we start at?
Node A?
Yeah, start at A. And then we have access to 3 edges. We have 4, 7, and 16. So which one's the smallest edge?
4.
We just take 4 and go to A to F. So yeah, very first thing, initialize this to SA. We have visited A, and then we have B, C, D, E, and F left. And then now we can just state that we have visited A to F. So we have reached F. So we do A, F, and we have B, C, D, and E left. And we just keep going over and over and over again. This is so fun to do. So we have A to F, perfect. Now we have access to a couple of nodes. We have 7, 16, 10, and 5. Now going back, let's take the smallest edge again, which is going to be D to F. So from D to F, taking U, we have reached D. So let's update the table again. So A to F, D to F, and then we can say A, D, F, and we have B, C, E left. Yeah, that's about right. Now going back to the table up the top again, we have a few different edges. We have 17, 7 again, 16, 3, 17, and 10. So the next smallest one is going to be 3. So from C to D, this edge right here, let's go back to the bottom, retrace our previous edges here to here. Now finally reach C, which is good. So we have A, D, F, C, B, and E left. Now going back to the top again, we have visited 3, so that's done perfect. And now we have access to all the edges now, which is freelancing. But question, can we backtrack in Prim's algorithm?
You can, right? You just can't backtrack in Kruskal's, right?
Yeah.
Okay. Okay.
So based on, since we have access to all the edges this time, what's the smallest one?
Wait, say that again?
Yeah, since,
A to
since we have,
B.
yeah, since we have access to all the edges now, so we have 7, 11, 10, 16, 17 to go to, we can
Mhm.
backtrack and go to 7 actually. So we can
Yeah.
visit A to B. So going back down, we have A to F, D to F, C to D, and then finally B to A. So we have visited A, F, D, C, and B. And finally, we only have E left. And the only way to access E is by taking 17. So taking that down, we can go over here to access E. And then that's pretty much it. We have visited every single node inside the graph. Here, and finally D to E. We have A, F, D, C, B, and E. Nothing left behind. And now finally, one more time, let's draw the MST4s again. Woo! So we have visited A to F, A to B, D to C to D, D to F, and D to E. Now just double check, let's just double check our previous answer. Just to make sure we are okay. We're not okay. What did I do? Again? This is lamers. Oh wait, no, that's the wrong one. Hold on. Oh no, I was correct. Woo, yay. Damn, that sleep deprived is really gonna hit me hard tonight. So yeah, based on this graph and our current graph, it's the same thing. Woo, we did it. And now just to make sure the tree's correct. So from A to B has the children, and F has another child, and finally D, and finally we have C and to E. That's it. That's the same thing as previously. And we're dunsies. Yay. So everyone okay with this?
Yep.
Okay, cool, yo. All right, so I'm gonna hate myself. Let's do dice first now. I hate dice stress. So for the actual exam, it's a who the fuck said that clap in there? So for the actual exam, we have to do dice draws, but we have to do a few extra steps though. And so it's the same thing as last time, except we have to hit the circle on the edge, or for this case, just highlight it and update the table every single step for dice draws, and finally draw the SPT. And then for this question, you can assume that it's already been initialized for you. So you can skip the first part, which is setting everything to infinity. So get over here. So if you want to, because it will be given to you, you can say that infinity, 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 infinity. You can skip the step in the exam. You can just go straight into like zeros, 1 and 2 and 3 and 4. So based on dice draws, exactly like prims, which is primary, what's our first starting node?
A.
Yeah, so we start at A. So we can state that A has been visited as 0 and the rest is still infinity. That's it. And now let's just keep going over and over and over again. So based on A, which edges can we use? Use A, A to F, A to B, A to 16. So based on Prim's algorithms, which one is the smallest edge?
A to F.
Yeah, so we're gonna take A to F as our visited node, but we'll still keep track of the rest of the other edges as our distance currently. So basically just saying, so 0 has been visited, so we can just count this as 0. And now from A to F, I have the ultra graph next to me. A to F is gonna be 4. A to B is considered as 7. And A to C is considered 16. And the rest of them are gonna be infinities. But since 4 is our smallest edge, we can just mark that as visited. So A to F, this could be our visited edge. And then cool, just mark this off as our one we have used already. Coolio. So based on our other edges, we have access to 2 more. We have access to 10, which is from B to F. We have D, which is 5, which is B visited D. So we can update our table one more time, saying, okay, from F to B, which one's smaller? Is 7 smaller or is 10 smaller?
7.
7, right? So let's not update our table. Just keep it at 7. But we do have to update the table for 5 because we have to keep adding it over and over and over again. So from 0, 7, 16, we'll come back to D, E is infinity, and F is equal to 4. However, for Dijkstra's, the way Dijkstra's algorithm works, we have to keep track of our previously used nodes and the one we're going to go for. So basically just saying, just add up your edges up together to reach D. So currently we can do 4 plus 5, which equals to 9. And it'll take 9, the distance of 9 to reach D. And that's it. Dicers just keep adding. And that's pretty much it. And dicers will only work for positive weight edges. Just means just all positive numbers. That's it. And so based on this table, what's our smallest edge?
A to B.
Yeah. So we can say, okay, perfect. We have visited A, we have visited F, now we have visited B. So from A to F, from A to B. That's pretty much it. And we just keep rinsing and repeating this whole entire process again. So now that we have access to B, we have access to one more edge, which is 11, here to here. So based on that, do we need to update our table by any chance to reach C? Because to reach C, we have 2 options. We have 16, which is from A to C, and then we have another option from A to B and B to C. Because this has already been a visited node, an edge. Call this here, here to here. We can say, okay, what is 7? That's a thing? What? That's so cool. What's 7 plus 11 by any chance?
18.
18, right? So based on our algorithm, which one's better, 16 or 18?
16.
16. So we'll just keep the table as is. It won't change at all. We'll just rinse and repeat it again. So we have 0, 7, 16, 9, infinity, and 4. So based on this table, because we have, let me highlight this to make it more clear. This has been taken, this is taken, and this is taken. So based on the other 3 options, what's the smallest edge?
F to D.
Yeah, so D. So we can say that A to F, A to B, and finally D to F here. So we can say that D has been visited finally, and then we have access to a couple more edges now. We have 3 and 17 access to. So let me update our tree again. Now we have access to 3 here to reach C again, and we have 17. So let's just keep track of the previous one. So we have 18, no good. So let's just try 4 plus 5 plus 3 now. 4 plus 5 plus 3, or 4 plus 5 is 9. So 9 plus 3 is 12. So to reach C again, we can update this with 12 this time because 12 is smaller than 16. So we can just update our distance from C to 12. So it's gonna be 0, 7 again, 9. We'll come back to E and 4. So based comparing 12 and 16, just choose 12 because 12 is the smallest number. 12 here now. And then finally, let's go back to the graph to reach E. So we have 2 options to reach E. This is going to be for C. For E, we have access to 4 plus 5 plus 17. So 4 plus 5 plus 17. Or we have access to 16, 3, or 17. So 16 plus 3 plus 17. And I'm not gonna do this in my head because that's gonna be we're gonna be here for a real long time, especially since I'm sleepy. So let's bring out a calculator. So 4 plus 5 is 9 already, right? So 9 plus 17 is equal to 26. So 26. Or let's do the other option, which is 16 plus 3 plus 17, which is 36. So comparing these two numbers, which one's smaller?
26.
26. So it's up to the table with 26 instead. So we do finally have access to E now. So based on our previous work, all of these vertices already visited. So between 12 and 26, which one's smaller?
12.
Yeah, 12. So let's choose 12 this time. And so we have access to A to F, A to B, B to F, and finally B to D based on our previous work. Cool. And finally, one last step. Let's actually get to E this time, which is using 26. So our table is not going to be updated again. This is our final time. We're going to do dice stress. So 7, 0, 12, 9, 26, and 4. So we can say that let's take 26 this time because it's small. It's the last edge. So we have visited A to B using this edge, A to F through this edge, D to F, C to D, and finally D to E. And that's it. So have you visited all our nodes now?
Yeah.
Yeah, so we're done. That's it. That's our final table. We have 0, 7, 12, 9, and 26, and then finally 4. So let's skip the rest of the tables because I thought this would take a lot more, but I guess not. It's so let's just we could actually just copy this if you want. But get over here. That's a lot of space for you. So based on our final resulting graph, we can just draw our forest. So from A to B, A to F, D to F, C to D, and D to E, and just draw a tree. Funsies again. So from A to B, A to F as A's children. Then we have F has one child, which is going to be D, and D has two children, so it's going to be C as our smallest alphabetical number, E as our big one. And that's our tree, and that's our forest. And it's also going to be your final answer too for your table. Should be this. So, everyone cool with this? That's one
Can you
thumbs up
scroll
to
up
you.
a bit?
Yeah, I got you. Want all the steps. This should be all the steps for distros. Oh yeah. For distros, little tidbit is that you can only use this for positive weights only. It's going to be useful for your super fun theory question at the very end. Such a good title. And also, since it's only positive weights, you can only add, you can't subtract any edges at all. And that's pretty much it for distros. Bowman fours, and on the other hand, you can subtract because Bowman four you can use both positive and negative weight. But that's gonna be after this because I only have one distros and I
So
hope
if you were to give us a negative edge weight as part of a graph and tell us to do distros on it, would we just have to skip that edge weight?
no, just say distros is not possible for this graph. That's it.
Okay. All right.
Hopefully, it's not gonna be like that. I can double check to
I
be
mean, I doubt he'll
honest.
do that, but
Yeah, I doubt it. Yeah, because from what I can see, it's all of it's positive. It's not negative at all. So if you do get positive, like as you research, if you do a research paper, just say you cannot use distros for this graph. That's it. So everyone cool with that? Okay, coolio. All right, so that's just dice trust. If you guys want to do another one, we can do one later. But I think Bowman Ford. I think everyone's here for that. I think everyone's here for Bowman Ford. So let's actually do Bowman Ford. For right now, it's all positive weights, but I can make not a janky one, but a semi harder one with negative weights this time. But since it's all positive, it's gonna be very, very similar to dice draws, like very like super similar. So let's just start. So same thing again for both Bowman Force and dice draws. Start at A, the starting node, and then we just make our way to the bottom. So same thing again. We have access to 4, 7, and 16. Which one's smaller? Oh yeah, I also gotta start this initialize this too. Forgot 0, infinity, 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 nothing else. So same thing again. It's the exact same steps as Dijkstra. So we have access to 4, 7, and 16. We're gonna choose 4 because 4 is the smallest edge. So we can reach from A to F. So let's update our table again. So from 0 for A, for B is gonna be 7, C is gonna be 16, and F is gonna be 4. So this is gonna be infinity, infinity. Take these out. Cats here. Losers. Whoop. And whoop. And then now, one more time again, as Dijkstra's, we have access to 5, 7, and 16. So one more time, so 4 plus 5 is 9 again. So we have access to D. So we have 0, 7, 16, 9, infinity, and then 4. And obviously we're going to take 7 this time again, because 7 is our edge we can reach. So we have A to F to B, here to here. And finally, one more time again, we have access to B now. So going back to the top again, we have access to 11 and 10, but since 4 is revisited, we can skip 10. And from C, we have 7 plus 11 compared to 16. So 16 is obviously smaller, so we'll take that one. And I skipped a step again. Of course I did. Choose D. Wait, no, I didn't. Yeah, no, I didn't. Then we take from after 7, we take 9. So we have 0, 7, 16, 9, infinity, and 4. So we're going to take 9 this time. Right, and then that's going to be not, that's not going to be infinity no more. A to B to D. Same thing as last time. We have access to E again. So based on the two numbers again, we have either 26 or 36. Let's take 26 again because 26 is a smaller one. So we have 26 in this table. And finally, at the very end, choose 26 because 26 is our last edge that has not been used. And E is the last vertex we have not visited. So finally, again, we have A, F, B, D. Did I skip C? Yeah, I did. And then C for here. C, D, E, F here. A to B, D to F, D to C, D to E. Pretty much it. It's the same thing as Dijkstra's, triple and four. Exact same thing. Only because this one has positive weights. But I'm gonna do another one, do negative weights. That's the part I'm gonna take a little bit more. I'm gonna take it slower basically. So from A to F, A to B, C to D, D to F, to the E. It's the exact same thing as I previously. In our tree, it's the exact same thing. But since I want to skip
C 12.
C12, is it 12? Oh yeah, it's 12. You're so right. Completely forgot to change 12. Whoop. 12. 12. Yeah, because of like Ariane said, it's to be 12. Completely missed that. My end. My bad. This could be 4 plus 5 plus 3 is equal to 12. It should be the same thing as last time, which should be 12. Here. So, if you can't tell already, Lumen 4 and Dijkstra's are the exact same thing. They're like pretty much the exact same thing, except The only difference between the two of them is that Blumenford is slightly slower in theory, only because you use positive and negative weights. And it gets slower when you have negative weights inside the graph. So just actually, since it's the exact same thing, just not waste our time too much, but let's add negative weights this time. And now you'll see the actual difference between both of them. So add a page here, the part I didn't add. So let's just take you. Now just go step by step again. Take this all out. Here we are, new graph. And then we just use, based on this, let's use -3, -1, 10, 11, 16, 3, 5, and 17. So for Dijkstra's, it's not possible at all, but for Blumenford, it is possible. So let's do it step by step this time. So starting at A, we have access to -1, -3, and 16. Which one is smaller? It should be -3, right?
Yes.
Yeah, let's just mark this as our visited edge. And we have access to B now. So let's update our table real quick. So we have 0, as to initialize it again. Infinity, 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 infinity. Now I'm gonna go like downwards this time the way Dr. Risk did it. So for anyone who loves Dr. Risk, here you go. So 0's been visited, so let's skip that. So we have access to -3. A to F is -1. And then A to C is gonna be 16. It's infinity, it's infinity. And so now we have access to a few more nodes. We have access to 16, -1, and we have 10 and 11. So let's do a little bit of math real quick. So from A and from C, we can use 16 or we can use 11 minus 3, which should be 8. Wait, yeah, 8. 8. So which one's smaller, 16 or 8?
8.
Yeah, so instead of doing 16, let's do 8. And then for D, we can't visit that yet, so still infinity. E and still infinity. And for F, it's -1. So we can't use 10. 10's too big, so let's use -1 instead. So we'll mark this as our visited edge this time. And now we have access to D. So for D, we can use 5. So we can use for D, we have either options is to reach. Actually, there's only one option, which is gonna be 5. So we do 5 minus 1. That's gonna be 4. So 8 again for C. We have 4. Infinity for E still. -1 was what we chose last time. So comparing these two, 4 is obviously going to be smaller. So let's choose 4 this time. So we have reached 4. We have access to D now. And D will give us access to 3 and 17 again. So for E, the more complex, well, let's see E's possibilities. So previously we can use this actually use only we have a lot of possibilities actually, except 10. So we have A to F to D. Let's choose actually there's only one possibility actually, the more thing less. So it's -1 plus 5 plus 17. It should be equal to 4 for this part, and 4 plus 17, it should be 21. Yeah, 21. So for E, yeah, for C, still 8, and then for E is finally just 21. So comparing it again, 8 smaller. So let's choose B to C. Sorry, one here to here. And finally, at the very end, we have access to the last one, which is 21. 21 here. So this access to E here to here. And now your final table, when you give the answer, should look like this. Let's just duplicate it. This isn't a whiteboard no more. Copy that. Should be 0, -3, 8, 4, 21, -1. And that's it for Bummerford. That's pretty much it, to be honest. It's the exact same thing as dice, except you can add in, it can add and subtract. Everyone cool with this? Here we go. And that's pretty much it. Damn, I'm going a lot faster than I thought. So, if everyone's completely cool with the Bummerford, let's do the last super fun theory question. The one I've been regretting the whole entire time. The last one. So,
Actually, can I ask a quick question?
yeah. What's your quick question?
Why didn't we add edge C to D?
C to D?
Yeah, because if you go
Mm.
from A to F and then F to D and then D to C, you can get to C in 7.
You get 2 to 7. Oh, good catch. I didn't think about that at all.
Yeah, because we did B to C instead of C to D, right?
You're so right.
And then that graph is different from the other ones. Well,
Yeah.
hold on.
No, I see what you mean. Like, so for C, we can reach from A to -1 plus 5 plus 3, which is 7, right?
Mm-hmm.
Yeah, if you're actually correct. Damn, I didn't catch that at all. And I made this graph too. Yeah, thank you. That's your damn job,
No, I mean, I'm
actually.
just doing it with you, and
Damn.
I just got a different number. So I was like, did I screw up?
No, I screwed up. No, you're good. And this super for us gonna be crazy tonight. We're gonna pass out soon, I swear. But you're right. Should be 7 actually. So at the which step was it? I think it was this step. We have access to D. Yeah. Should be 7 this time. Yeah, you're right. Thank you for catching that actually. But yeah, thank you. So yeah, that's actually it for Bummerford. Everyone cool with that actually? Okay, cool. You have a question, Emma?
Oh no, I don't.
Okay. So, are you guys ready for the theory part? You have to memorize by heart by tomorrow. So, the last one. This one, I honestly recommend looking up online because I also don't have this memorized at all. So, single source shortest path. Usually use dice trust for this because dice trust is a little bit more faster compared to the other ones. I really should have taken the picture of the board yesterday. I don't have these memorized at all. Dice trust.
I have it.
You do? Wow. So, does anybody know their runtime for actually for all of them based on the final review?
I mean, I don't have it memorized, but I have the picture from
That's
off the
good. That's
top.
good. Hey, that's good enough for me. I'll also take picture from in class too, because I also don't have these memorized at all. So I'm gonna steal it. Thank you for someone who sent it in the chat. Wow, that is horrible runtimes. Okay, so my God, that's gonna suck to memorize. So I gotta add that part. So for distros, without the heap, so without and then with heap. So without the heap, thank you for someone to the picture in chat. It's going to be n squared, which is really bad. It's horrible runtime. But with the heap, it's going to be m log n, right? M log n. And for Bumblebore, it should be something as a textbook. It's going to be m times n. For Warsaw, it's going to be n cubed, always. Warshaw's the worst. We never talk about Warsaw because it's the worst. And then for all pair shortest path, without the heap, a little bit, it's exactly like Warsaw, which is bad. And with the heap, it's going to be a little bit more slower, but not too slow. So without the heap, it's going to be cubed. like Warsaw. Warshaw's the worst. Thank God it's on the exam. And we have, with the heap, we have m times n times log of n. For Blumenford, exact same thing. We have m times n squared. So, based on our runtime, thank you, Matthew, for sending that in chat. Which one is the worst and which one's the best for single source shortest path? Does anybody have a clue which one it is?
Is it dexterous?
It is dexterous.
Okay.
It's gonna be without the heap though, right? With the heap, right? Not without, that's gonna be bad.
Yeah, with.
Yeah, with the
Yeah.
heap. Because log will reduce n by a little bit, but not too much, but should be enough based on it's an ugly ass m compared to Bemenford. So the best runtime is gonna be Dystra's. With the heap. And then the worst, always gonna be Warsaw. And so for all pair shortest path, which is gonna be the best? I'll give you a hint for this one, because this one's a little bit more harder to see. So for both single source and all pair, they're the exact same thing, except obviously we're gonna have to square it, like n to the power of 2. And same thing for dicers, except we have a log in between both ends. So we use the exact same logic. We can say that, okay, we're gonna multiply n twice, except one of the n's can be multiplied by log, which will reduce that its own n by a little bit. So dexterous with the heap is gonna be faster, and for worse, it's gonna be both dexterous without and Warsaw, because they're both n cubed. Yeah, should be n cubed. So we have dexterous with the heap. I cannot spell dexterous. It's crazy. I can't even pronounce it correctly. I've been saying it wrong the whole entire time. And that's so funny to me. So with the heap, and then worst, it's gonna be both dexterous without the heap. Because both of them are gonna be n cubed. Warsaw should always be n cubed. And so now with the actual tricky part, let me look it up one more time. Okay. Comparing these two algorithms, let me just draw a line. Which one will be best if all the weights are positive?
If all the weights are positive, you go for dexterous.
Yeah.
Well, real quick, for the all pair shortest paths,
Yeah.
wouldn't the worst one be Bellman, since like typically m will be greater than n? I mean, like not in all cases, but typically there will be usually more edges.
That's true. It really depends on m, right?
Mm-hmm.
It really does. So that's something that's actually really true, because m is kind of really important, especially for the exam. I know what it is. I can't really tell you. I can't really decipher it right now.
Yeah.
But
like if there's like more nodes than edges, then you would want to go for like a Warsaw. Like
yeah.
if you knew that it wasn't all positive.
Exactly. So Bumford, if it's if and only if m is greater than n. That's it. So for all positive weights, always dexterous, right? Because you can use positive for dexterous every single time. So without writing using my ugly handwriting, let's copy it. So for best, it's going to be dexterous because it's the smallest runtime and always all positive weights. So, but trick question: which one's better for negative and positive weights?
Is it Belmont?
It is only because Bowman Force can only use both positive and negative weights, right? And because dicers, we can't use dicers no more, so let's just take dicers out. So comparing m times n and n cubed, obviously m times n could be better because n cubed is going to grow exponentially faster compared to m times n. So in theory, Bellman-Ford is best for single source shortest path. It's a long name for no reason. But what about all pairs? Which one will be faster since we can't use Dijkstra at all? It's going to depend, right? It's really going to depend on m. Because let's say, for example, if m is going to be, if m is equal to n, which is not possible at all, but just for little funsies, if both of them are the exact same thing, technically they're both n cubes in theory. But if m is greater than n, then both Bell and Warshaw are the best. Oh no, actually, wrong one. They're the same. Both of them are the best. But if m is greater than n, then Warshaw's the best. That's it. But it's really gonna depend on m, especially since they're the edges, and edges are kind of important. But that's pretty much it, to be honest. That's all. That's the whole entire review, to be honest. Like, if you
Is
got
he
more,
going to,
what's up?
sorry. Is
You're
he
good.
going to ask us for like all of this, or he just wants like the basic runtimes of the chart?
This is just the basic runtimes. He's gonna ask you which one's the best, and you have to explain why it's the best. That's why I have you the runtimes, because you can use the runtimes as a justification.
Okay. All right.
Well, yeah, everything on this review should be on there already. And then, yeah, it's only the first one's gonna be a little more tricky because you don't know which pseudocode is gonna be. But I can only tell you it's gonna be based on sorting and based on medians and medians. That's it.
For the recurrence question?
Yeah.
Okay. Also, I remember you saying yesterday that something about subproblems and recurrence formulations. What do you mean by that?
Okay. So, little theory, now time for little theory. Does anybody know if Dijkstra, Spellman-Ford, and Warshaw are considered greedy or DP?
I think Dijkstra's is greedy, and then
Greedy,
Bellman and
yeah.
Warsaw are DP.
Okay, little fun fact. Dijkstra is also considered DP.
Oh,
Little fun fact. Yeah, so that's why I love Dijkstra for a little bit. But the only case I said that to memorize all their subproblems and recursive formulations is only because for my exam, I had something like the final review or what's the homework. I think it was the homework where like you're given a problem, you have to use Dijkstra to solve it, right? I think that was the homework. Hold on, let me double check. But that was my exam, and that killed me because I couldn't use Dijkstra. I had to use Bellman-Ford. I didn't have the shit memorized. So I thought it was gonna be exactly like that, but thankfully it's not. So for that, you don't have to memorize it at all. Just know how to trace it. Just know like how to do it by heart now.
Okay, thank God. Okay.
Yeah, I know, right? Lucky asses. But other than that, I'll send this in the chat by the way. This whatever monstrosity I worked on. I'll send
Okay.
this in the chat as well. And
So
yeah,
Dijkstra's is DP, and then Bellman-Ford and Floyd Warshall is
all of it are DP.
greedy.
All
them
three
are
of them are
DP?
DP. Yeah. The
Oh,
greedy is actually Prims and Crisco's. Little fun facts.
okay.
Only because Dijkstra simply worry about all the edges, Bellman-Ford, all the edges again, and then for Warshaw, it's just Warshaw. Warshaw's the worst. But yeah, that's pretty much it to be honest. Unless that way Does anybody have any other questions?
Yeah, can I ask you about the runtime of medians?
No.
So like so like in
Uh-uh.
my notes I have it as like O of n log n, but like I also
Huh.
have like somewhere else where it says like constant time. So would it be considered O of n log n when you're using median of medians for like quick sort?
Maybe.
Sterling, do you know? I feel like you know the answer to this.
I can't say the answer at
For
all.
medians, I think medians for selection it's O of n, but if you use it, I think you use it to get a perfect median for quick sort to make it best case scenario. Because it was on exam 1, you're supposed to use it for the O of n selection algorithm, I believe.
You do. Hold on.
Mhm.
It's right here somewhere. But I can't say which one it is because you're too close to the actual question, so I can't say what it is legally. I'll get fired. But I can show you the notes I
Okay.
took. Wow, look at these
If you could just send it to
amazing
me on
notes.
Discord, then that'd be
No,
great.
wow, look at these
No.
amazing notes. And it's oh look, I have to edit this notes real quick. Oh no, it's actually gonna be this one? What? Oh no.
Whoa.
Oh, I missed it. Oh, that sucks.
Thank you. That makes more sense. Might go for real.
But yeah, I will
Wait,
let
I
you
didn't
know.
see it.
That's
I'll
hey,
tell you. I'll
hey,
tell
hey,
you.
that's
I'll
that's
tell
Okay,
you.
hey,
thank you,
that's not
thank
my
you.
fault. That's your fault.
That's my bad. I was looking for my exam.
But if you see this question exactly like this and all the comments and everything like that, you'd be okay. And definitely follow these tips.
Oh, the tips, it's right there on the right.
Yeah, wow, look at these amazing tips I wrote. It's definitely not medians and medians, and definitely not one of the sorting problems that uses medians and medians. Nuh-uh. Could never. That's so funny. Nuh-uh. Legally, I cannot say yes or no, but I can say it may or may not be. Who's to say?
Legally, he is obliged.
Legally, I can't say it, but writing it down, I didn't write this down. That wasn't me.
It's
It's
true. I
definitely
mean,
not
no
on
one
the
saw your
screen.
hand do it.
It's definitely not on the screen right now. And I forgot to erase it. No, it's definitely not like that. But yeah, it should be. It may or may not be like this. But yeah, other than that, because I also have my midterm, and it's definitely very weird, so I'm not gonna send this at all.
Did
But
you take yours with Panarangan?
Hmm?
Did you take yours with Panarangan?
no, take him a go, Paul. I count him as my TA.
Go Paul is Panarangan.
Oh, is it? Oh
Yeah, I feel bad
yeah.
for you.
Me
His exam sounds way
too.
harder.
What? I got like a 34 out of 100. It's not that
Oh
bad.
no!
It's not that
Let me guess. Was
bad.
that the high
No, the high was like a 50.
out of 100?
Yeah.
Oh man, retired.
Thank God we're not in his class. They
Yeah.
have another algorithm that they need to study. I can't remember what the name of
Rushkas.
it. Yeah, don't even
Huh?
get me started on that. I just zoned out and off
They're
silent when you started
they're
talking about
also
that.
doing the binary bits counting one that we went over for like one day. Like a
Oh,
graph.
the Huffman code?
Huffman, yeah.
Oh,
They're
Oh,
doing
that
that
do
sucks
too.
for
that in
them.
dance class.
Yeah.
I don't
Oh
remember Huffman.
yeah. Forgot Dan does algorithms too. I totally forgot. He's so weird for that.
Eat the goat.
Yeah. That was so funny when I saw that. Okay, so for the cut part for prims and Cruskos, thankfully, it's only for prims. For Cruskos, just this. That's it.
Yeah. I
Legally,
think because
that's the
his
only thing I can
office
say.
hours, he was talking about how doing it for Cruskals is stupid, is what he
It is
said. So
stupid.
Yeah.
I also agree. It's stupid. I
But I
also
think he's only gonna ask for
agree.
Prim. Like he said that.
Okay, did he? Okay, perfectly. Yeah, he's correct. It's actually just like this. So for Cruskos, it's stupid. For prims, you actually have to do it like this. That's it. But basically for the cut, basically for T, it's what you have currently inside your tree, and then V minus T is currently we have remaining. That's from the original graph. That's it. It just a fancy way of saying like, hey, subtract what you have from the original graph, what you have right now. Subtract them. That's it. You don't have to prove it, just give the table. That's it. Yes, I can go back to the last question real quick. Flip the chart. Yeah, I got you. Yeah, no worries. Like the super fun theory question, right? I love that title. It's such a good title. So this is the thing for the last. I'll send this in the chat, by the way. I'll send this whole turn notes in the chat if you like miss something. No worries, no worries. But this is just a chart. The runtime's given in class. Thankfully, someone sent in the chat, so I just copied that. Thank God. And then the best and worst. And then for all, I'll finish this real quick. For all positive weights, I'll finish this real quick. Weights. I probably spelled it wrong, but I don't care. This isn't my exam. This is yours exam. So if I do it wrong, you are all gonna fail. And then weights. And that's it. Everyone cool. I'll let people finish in chat. From the previous material. Okay, so from previous material, look over homework 4 if you didn't do it. If you just send a meme, I will give you 100 still. I think they're very funny. But look over homework 4, especially the Crucibles, Prims, Dystros, and Bellman Force. Like try that on your own. I did it here already, but you can try it on your own again if you want to. And from previous semester, from the previous exam, just do the DC recurrence theorem, like this part. Just memorize your theory. What is A? What is B? What is f of n? And then if C is less than, increase greater than or equal to 1. And that's it. That's like the only previous material you should like really focus on.
Do you think we should potentially look at any of like the Sweepy or hotel stuff, or would that just be kind of like a waste of
Nah.
time?
That's gonna be a waste of time.
Yeah.
No DFS, BFS. I think that's also stupid. Do it all over again. I guess it's like last exam. I think y'all guys are doing pretty okay because I'm grading that one. So y'all guys are okay. Y'all guys did like DFS and BFS for like two times in the last exam, so y'all be okay. For DP, technically no. There's no subproblems for recursive formulation, nothing like that. But Caleb would say there is DP because Dijkstra's, Bellman Force, and Warsaw are all three considered DP type of algorithms. But other than that, no actual subproblems of recursive formulation. Just know how to trace Bellman Force and Dijkstra's.
We don't have to prove anything either, do we?
No, thank God. That's gonna suck to read.
Okay.
You sure? He said there's something about like possibly doing like a cycle proof.
A psycho proof. He's so funny. That's so funny, actually.
I think we all hate proofs. That'd be awful.
I think he said if there
know.
was a proof, it wouldn't be proof of correctness, but it would be either like the cycle property or the cut property. One of those two.
Well, we just did the proof right now. Well, the table. That's considered the proof, by the way.
Yeah, proof by visualization. There you go.
Exactly. Hell yeah. Proof by visualization. Hell yeah. That's what he just goofing around, to be honest. It's actually really
silly.
funny. It's really funny. I like it. But yeah, basically DC, yes. And the rest of the review. Yeah, exactly. So for the actual review, go over like the section that says the most important section, like that part. Let's go Bowman, Crucibles, Dystros, Corinne, and then the funny, super fun theory question at the very end. I forgot what it was called. Let me check it out real quick. It's actually I hope it didn't spoil the midterm. That's gonna be really fun. Really funny if I spoiled it already. Check. Yeah, the shortest path table, just that. So for proofs 5 and 6 on the review are on the final. No, ma'am. Thank God. Because if you seen the proof for cut property, that shit's long. It's a really long proof. And for a simple path, just good luck with that one. That's like n times exponential.
That was terrible.
Yeah, we're not doing that. I'm not grading that either. If that it's on the exam, it's definitely not. Spoiler alert. I'm not grading that question. That's good. That's gonna be like a couple weeks to finish. So thankfully no proofs because we have no time to actually read and grade all the proofs. That's gonna take way too long. So no proofs, just DC and whatever I gave you on the review right now. And that's it. If you understand it, you'll be okay. And plus, for Bowman 4, just look over some more like YouTube videos. I hate saying that, but just look up more YouTube videos for both Dysters and Bowman 4. There'll probably
how
be
to
more.
how to trace it or like algorithmically how it works.
Just how to trace it and also understand how it works, like why we chose the smallest one and why we're gonna subtract. And that's it.
Okay, so we don't even really know the pseudocode.
No, no pseudocode. Thankfully,
Thank God.
that's what I'm saying. For midterm 3, I'll let you know my progress. So I'm still grading it. We're grading that for a real long ass time. I'm only taking a long time because I'm grading the first one. So the DFS and BFS question that has cut properties and blah 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 blah. So I forgot what number I was on, to be honest. Hold on. Let me double check. Let me open up my notepad.
He said y'all would finish in like 2 weeks.
Well, 2 weeks is reasonable. Not in 1 week. Let me open up this thing real quick. Last time I was on 50, student number 53, but that sounds really, really mean. So I must say their names. Actually, I can't even say their name. I'm illiterate. I forgot. So last time I was on, dude, I graded 53 students already, and the rest of them are still behind. So give it like another week. I'll catch up, I swear. It took me like 3 days to do 50 students, so I might be here for another like 3 more days, and then maybe I'll finish it.
And then you can start grading finals.
I know, right? And the homeworks. Don't forget about the homeworks now.
Yeah, it's been months.
I know. Well, I finished my part. I did hotel and the bin packing, the one of the greedies, and it's just the one TA I don't want to shout who's always busy like me, and that's
Hard?
it. No, I didn't say that. That was you. But yeah, it's just we're all busy to be honest. Like we all have our classes. Hey
Oh, he's in
Tarek, no, no.
He's out of us.
I'm so sorry, Tarek. I didn't say mean things. I swear. I just said we're all busy, like like me. It's okay. I swear.
Get him.
By the
What
way.
the fuck? I thought you left.
Nah, bro, I was here the entire time. Anyways, wait, are you going to Proctor tomorrow?
Hmm?
Are you going to Proctor tomorrow?
Yeah.
Okay,
I'm a bully every single one of y'all. And if I get fired, it's worth it. But it's okay. Midterm is gonna take a while to grade. Like it's a really long exam, especially my fucking question. I hate every single one of y'all. I'll let you know my average to grade exercise 1 is like 10 minutes to grade 1 student. Only because y'all gave some really interesting modifications. I love the essay y'all guys give me. It's so fun to read at night.
Try to add as many sentences as I possibly could. Just
Why?
Just,
Why
Yeah,
do
you
you
so
do
give
that?
us partial credit.
you know,
Why? I'm gonna give you a 0. You know the right? It's not even partial credit. What are you guys talking about?
the more
Like
the
an
merrier.
automatic 0.
Yeah, eventually you'll get tired of reading it and just give us full points, hopefully.
Nuh-uh. Well, okay, a little spoiler alert, by the way. Some of y'all did it out of order, the tree. So I have to give you half points for that. It's still correct, but it's out of order. So that was fun to grade.
I don't even want to look at my exam.
Don't worry, I haven't reached yours at all. I haven't reached yours at all.
Just skip it.
Actually, I should grade yours right now. What do you mean? What are you talking
No,
about?
don't do that.
Uh-huh. What do you? I'm not even clocked in. Fuck. Oh, now I should really grade. This sucks. I lost 2 hours of work again. Ugh. Lame. Char, you can laugh at me now.
Oh,
Completely
he
forgot
is.
to
You know,
clock in.
but it's not work if you're having fun, right? You know.
What the fuck you mean? This is fucking charity work. This isn't a fucking pro bono. This is work. I've been clocked in already. I forgot to clock out. This is so fun. I forgot to clock out, so I can't really clock in for the rest of the day. This is so fun. Let's see how much I've accumulated last night. Damn. I can't scroll down for some reason. Okay. I can't see still. Okay. I worked 15 hours last night. That's crazy.
Oh my god.
I gotta get that fixed
W
by
bag
tonight.
chasing. Not gonna lie.
Legit, I have reached. Wait, I haven't maxed out at all? Huh? That's crazy.
You gotta max that out.
I haven't maxed out with the 15 hours. Maxed out last week, not this week. That's crazy. I guess I officially work 15 hours, and y'all guys are my witnesses. So yeah, good luck with that. But yeah, I'm gonna grade yours real quick. I know your name. I don't know where I lost it. Fuck. Oh, there it is.
Grade Sterling's. I'm sure
No, no, no.
you'll be happy. If you look at my grade, you'll be very disappointed.
No. Preposterous. Let me.
It
I'm
was
gonna
very bad.
look. Your tree is correct. What are you talking about?
Look. I didn't have any time to study, so I'm not even gonna look
Okay.
at that grade.
I'll let you know. You got the DFS part correct.
I don't want to talk about it.
I don't know about your BF. You memorized the theory? Damn. That's crazy, not gonna lie. But yeah, I'll grade yours later. Don't worry. You have to go back anyway. Sterling, you're next.
Yeah, please.
I got you. Only because I have your name on chat and you can't leave.
I think we should give Sterling like honorary TA of the year.
That's true, maybe.
I'll come back.
Oh, I graded yours already. I gave you, if you want to know, it was not
Sure.
bad. I gave you full credit for like exercise 1.
Oh, nice.
Yeah, I'm doing it by last name. So anybody who is before H, I've graded yours already. I don't know about middle names though. Let me double check that. Those still count. What is it? I can't. Oh damn, I'm horrible at spelling. But yeah, that's pretty much it to be honest. I'm kind of exhausted and also need a grade. But does anybody have any other questions? I'm always gonna be here until everyone leaves. But theoretically, if you gotta stay, I can't leave. I can kick you out, but I can't leave theoretically.
Where in the chat did you put the notes you did?
Oh yeah, you're so right. Totally forgot. Be real
Very
quick.
top.
Let me fucking stop recording. So don't check my files. I swear it's not bad. I just don't want no one to know about my fucking classes I take. Okay, save it. Okay, maybe I'll start sharing my screen again. Maybe I'll think about it. Chat. But yes, I am doing it by last name, by the way. So yeah, that's been fun. Attach this device. Filled out. Open. And Target, if you're still there, you can use the notes, by the way. I'm gonna send in the chats if you want to use it for your office hours. But yeah, it should be, yeah, it's there in the chat now. So yeah. That's everything you should need, I swear. If not, I'm gonna bully you tomorrow. So it's up to y'all. If it's up to how y'all want to do it. But yeah, everyone cool?
Thank you.
I'm Sterling. Oh, I'm tired. So I'm gonna play a little game. I'm gonna play kicking everyone out who doesn't speak.
Thank you.
Thank you, and have a good one.
Whoa.
Thank you.
So like, where would I
you.
get the recording at?
Huh? Oh yeah, I guess I'm recording this bitch. Hold on.
Yeah, can you just
Yeah.
send it to my Discord, you know?
I'm